comparing the mean, median, and mode. An outlier is an observation that falls well above or below the overall data. So here, when you look at the graph, this portion, it tells us the data we have is pretty much symmetric, right? However, it has an outlier. So this outlier, it will make the mean change. It will push the mean from here into here. So this is the mean, but because the outlier, it pushed the mean into a larger number. So this is the mean 1, and then because the outlier, they make the mean turn to a larger number. However, this mean, the new mean here, it doesn't represent the majority of the data, right? So we have to prevent when we have the outlier. What can we use as a better tool to perform our data? So when we look at the center, all three measures, which is mean, median, and mode, they all can describe the center. Mean is the most frequently used and considered the most useful. Advantage using the mean. Mean is a reliable measure because it takes into account every entry of the data set. Disadvantage of using mean, greatly affected by outlier. A resistant measure is one that is not influenced by extremely high or extremely low data or value. Therefore, the mean is not resistant, but the median is resistant. Median never got affected by the outlier because it just focused on the middle. However, this advantage of the median is not sensitive because when you have a lot of outlier on your data set, the median will not represent it very correctly. So it's not sensitive to the specific size of the data value. So here you need to know mean is not resistant because when there's an outlier, the mean will be changed. Median is resistant. Median is resistant, but median is not sensitive to describe the data tendency. Okay, so that it has a good and bad that between mean and the median. And we will talk about more that part. Comparing the mean, median, and the mode. So here I have the data set. We need to find the mean, median, and the mode. So are there any outlier? Which measures of center tendency best describes a typical entry of this data set? So finding the mean, we add it all together, right? And because I have 6 of the 20, so I multiply 6 with 20. And then I add 21 multiplied by 4. 22, I have 3 of the 22, so I times 3. 23 I multiply by 4. 22 I multiply by 2. And then I add 65. Add it all together, then divide by 20 because the sample size has 20. So do the calculation, I get a mean is approximately. I didn't put an equal sign here. I use the two kind of like curses. So we call this is approximately. approximately 23.8 years. Finding the median, because the data entry is an even number, so we take the middle two, right? The middle two is this two. So find the average of the middle two that will turn to the median. So the median is 21.5 years. Finding the mode is 20 because 20 has the most frequency. The mean takes every entry into account, but it is influenced by the outlier of this data, 65. Here you can see, majority of the data they have that very closer attribute. But 65 is a little bit kind of like far away, right? So we treat the 65 as an outlier. The median also takes every entry into account, and it is not affected by the outlier. So in this case, the mode exists, but it doesn't appear to represent a typical entry. So sometimes a graphical comparison can help you to decide which measure of central tendency best represent a data set. So we look at the graph here. So the horizontal axis here that represents the age of the study in a class. So the tendency of this graph is a little bit kind of like skewed. Let me erase it. It's a little bit kind of like skewed to the right, right? So this is the peak is here, and then the tail got affected by this outlier. So because this number make the mean push from the middle to the right. So the highest peak here is your mode. The average got pushed to the right, so the most right here it turns to the mean, which is your average. So between mean and the mode, that will be the median. So in this case, it appears that the median will best describe the data set since it is not affected by the outlier. So mean is a better description to represent the center. When there's no outlier, when your data has no outlier, which is pretty much normally distributed, then mean is a better measure to describe your center. But like this example, it has an outlier. So your mean is no longer present the overall data information because it got affected by the outlier. Therefore, we use the median to represent the center. I hope this makes sense to you. So here has an app, you can play with it. Now I'm going to start here. When we go back to class on Thursday, I will continue from weighted mean. So this is section 2.3, and I will go start from here and then continue 2.4 and 2.5.